Hello. Okay, so for this assignment, the automation one, the best way that I thought in the given time frame to achieve templatization of the entire configuration was to divide these devices into each type. So I have three types, which is access router, core routers, and edge routers. So the access routers are R1 and R2. The core routers are R3, R4, and R5 is the edge router. Now, talking about the first part, which is version control and change management, I have my personal GitHub repository in CSCI 5840 where I am updating all the configurations and all the scripts and automation that I'm putting it here. I'll talk about what I have in this repository in a bit. Okay, so first I'm going to talk about the backend setup that I have and how I have templatized each of the router configurations. So this is my directory structure, um, and under lab 4, I have configs, templates, and a Python file, which I'm going to talk about in some time. Under templates, I have three Ginger 2 templates. The first one is access.j2, second is core and edge. And as the name suggests, each of the types have each their individual templates. So for example, if I'm gonna open access.j2, I have a bunch of configuration based on how uh, the the access routers configuration looks like, and this is the code. And where this basically picks up from is the configs folder, which is, let's say R1 is the access router. And as you can see here, I have a YAML file. And this is a YAML structure that I created. For example, there's VLANs, and under VLANs, you can add as many VLANs as you want. This is the VLAN ID, what is the name, what is the IPv4 address, v6 address, is DHCP enabled or not, the IPv4 virtual router address. So I'm doing VRRP between R1 and R2. So this is the virtual IP address, v4 and v6. And if you want this particular VLAN to talk OSPF or not, OSPF v3, which is IPv6 version of it. And so I have a bunch of other YAML formats, like for interfaces, um, for routes. For example, this is static routes, static IPv4 routes, which basically mention this is the destination prefix and what is the next hop IP address. And you can add as many as possible. And then I have IPv6 static. Um, then I have routing protocols such as OSPF and RIP for access routers. I'm gonna show you how it looks for core. But in OSPF, I have the OSPF ID and what networks to advertise and form neighborship with. So there is a prefix and the area. And for RIP, I just need prefixes. And if I show you the YAML for core routers, actually, let me show you for r2.yaml as well. The only difference in R2 is that it's a DHCP server. So this VLAN in this case has DHCP enabled as true, and then you can just give a range, like from where to where you want the IP addresses to be allocated, like 110010 and 110050, just for an example, the default gateway. And since this is also a DHCP v6 server, You can also add DHCP range for v6 addresses. And yeah, that's probably the only difference for R2 in the access router section. All right, so this is an example of core router. R3 and R4 both have the same config, except the IP addresses and all the variables change. Like for example, I have two SVIs here. VLAN 50 is for OSPF, VLAN 100 is for management, and you can assign the IP address, the v4, v6, and what is the OSPF v3 area if it wants to talk OSPF on that interface. Similar to the access router, the stuff is pretty similar here. What changes here is even the static and IPv6 is the same. What changes here is just this part, which is BGP and not RIP. Access routers talk RIP, but the core routers talk BGP to the edge router. So here we have BGP. You can mention the AS number that this particular device talks, and the neighbor IP address. What is the remote AS? What is the neighbor IP again? And what is the remote AS? These are all the networks to advertise in BGP. And similar to access router, we have OSPF here, except we also have redistribute BGP routes here, which is set to true, which basically means um, redistribute all BGP routes into OSPF. R4 looks very similar because it's again a core router. I have R5, which is the edge router. Again, it's a mix of both access and core router templates. You can have VLANs here, multiple interfaces with the interface name, the IP address. Switch port mode is null because it's an L3 link, and the routes are very similar. You have static routes, v6 and v4, and you have BGP routes here. And what changes here is that you have IPv4 networks and IPv6 networks which are getting advertised, but rest everything remains the same. Okay, so that was about how I have templates for like I have a YAML file, and you can use this YAML file to form a configuration. Now, how I do that is in the backend, I have this Python code called generateconfig.py, and what it does is you can give a config file here, and you can tell what type of router is it, like is it access, core, or edge, and based on that it will generate a config. For now it is just um, spitting the config out in the terminal, but in the future we can obviously save it in a file. And how I do that is I just put python 3 hyphen hyphen config, and this is the path to configuration. So let's say python 3 generate hyphen hyphen config slash r1.yaml, for example, and the type of router is access, and there you go. It's using the r1.yaml and picking up access.j2 file in the templates folder and generating this configuration based on that. And if you want to see for core, if I use r3.yaml, it's gonna generate BGP, for example, here. And just to show that it actually does work. If I change this to access, it's gonna error out because it does not have any rep configuration. And it, as you can see here, it says ticked object has no attribute for rep. So we know that it is using the template, the Ginger 2 template. All right, this was all about the backend stuff and how things are working in the backend. I'm going to talk about the front end now. So I have this is my directory structure again, and this is my code, my front end code, which I'm not going to talk about in this video, but it's a Flask app that runs on localhost 5000, and this is how it looks. It's a one-stop shop for all your network automation needs, and it has three tabs: Grafana dashboard and add a new device. I'm gonna first show you the Grafana dashboard. I've embedded it in this website itself, and as you can see, it just updates lifetime. I can change this to R2, and it shows me R2 CPU load and the interface stats, and it's like mini Grafana here. I can literally even, if I have multiple dashboards, I can even go to other dashboards. But that's how I've embedded Grafana. Now I'm going to talk about the add a new device form. So I have this form where it initially first asks you what's the device name and what's the router type. Okay. First of all, I just want to point out that whatever form I'm filling here, and once I click on submit, it basically stores whatever file or the YAML file that it gets. It stores it in this folder, lab 4. And the reason I'm just showing it is because there is no file right now, and it's going to generate and come up here. So I just wanted to point that out before we start submitting the form. All right, so first let me just start filling the form. Let's say the device name is R1. And here there are three types of routers: access, core, and edge. For now, let's just stick with access because R1 is an access router. And I'm gonna quickly fill in all of this information. So these are all collapsible sections to make it look a little neater. If I click on VLAN configuration, it gives me this entire form. So I can have a VLAN ID. Let's say it's VLAN ID 10. What's the VLAN name? It's H1, H3. Let's say this is 11002. I've already filled this format, so there are a bunch of things here. DHCP enabled. So this is a drop down. I can choose yes here, and it'll show me a bunch of more options, like what is the DHCP v4 range start. Let's say 110010 here, and the end is 11050. The default gateway would be 11003. This is the v6. This is the virtual router address, as in the virtual IP address of VRRP, which is 11003, which is similar to, which is the same as the default gateway. Similarly, we have 2010::3, and this particular VLAN does talk OSPF v3, so I'm going to put the area. Now I can add a VLAN here and it'll ask me the same questions here, but for the time being, I'm just not adding another VLAN. And as you can see, I have another button called remove VLAN. And if I just click on remove, it removes that entire section. Okay, so that's VLAN configuration. Let's move to interface configuration. The interface name, let's say it's Ethernet 1. The v4 address would be, I don't know, 192.168.100. Actually, let me add two interfaces. Let this one be an L2 interface. You can also add a v4, v6 address, and MTU. You can configure it, but for now, I'm just leaving that. Um, I'm putting switch port mode as trunk. It's just an L2 link. I'm gonna add another interface similar to the VLANs. I have add interface and remove interface. Let's say Ethernet 2, and now I'm gonna assign an IP address. Let's say this is 2020 colon colon 2. I'm gonna leave switch port mode because this is an L3 link, so it's not gonna be access or trunk. Um, that was interface configuration. This is static routes, so I can have as many static routes as I want. For now, let me just put the default route. This is the prefix, and what would be the next hop? This is the management IP address. I can add another static route, but for the time's sake, I'm just gonna remove the route for now. For v6, again, I'm gonna put a default route here. This is the management IP address, and as you can see, I can add a v6 static route as many as I want, but I'm not gonna add it for now. Okay, OSPF configuration. The OSPF ID is 1. The network that I want to advertise is 1100, and the area is 000. I'm gonna add another network prefix 1200, and the area is 000. So I have two OSPF networks here. I'm gonna add RIP configuration as well. So let's say I'm gonna add 11 and 12. Yep. And similar to OSPF, I can add as many RIP networks as possible, but I'm gonna just add two. And now once I click on submit, it will basically save, yes, it in this file lab4 called r1access.yaml. This is the host name, whatever host name that you give here, and the access is basically whatever router type you're using here, access core or edge. And if you see here, it has populated everything that I filled it in the form. Like, for example, VLAN 10, this is the subnet, this is the subnet, and DHCP enabled is true, this is the OSPF area, and all the range that I gave here is here. And if you see here, interfaces Ethernet 1 was an L2 link, so switch port mode is trunk, but V4 and V6 addresses are null. And if you see here, Ethernet 2, there's a V4, V6 address, but the mode is null here. Similarly, I have OSPF static routes here, OSPF routes here, and RIP networks here. Now, I'm gonna generate, using my Python code, I'm gonna generate the configuration. So how I do is I just do Python 3 generate config.py hyphen hyphen config r1 access, and hyphen hyphen type would be access, and there you go. It has generated a config for me. For example, if you see here, we have VLAN 10 with the same name, DHCP server, subnet, blah, 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 default gateway. This is switch port mode trunk Ethernet 1, but if you see Ethernet 2, which was the L3 link, it says no switch port IP addresses. And VLAN 10 was talking OSPF v3, and we have router OSPF here, the static routes IPv6 and IPv4, and router RIP. That's how I'm doing access Code is very similar. If I click on core, it'll give me the same configuration. Like, for example, I'm just gonna quickly fill in some information here. Um, the VLAN config, the interface config, the static routes, everything is pretty similar to what we had previously. I'm just gonna add BGP configuration for now to show that this particular thing is different. So let's say I add 63,000. Neighbor IP would be 103,002. This will be 60. This is the remote AS number, which is the neighbor's AS number. So let's say 65,000. And if I add another neighbor, let's say I'm gonna add a V6 neighbor this time, and the AS number is 65,000. This is the BGP network prefix, like whatever networks I want to advertise, let's say 100.0.0/29. I can add another one like 103.0.0/30. One last. And if I click submit, it creates another YAML file called R3 core. Since I did not fill any of these information, it's just null. But if you see this part, which is BGP, it says neighbors 65,000, IP address, whatever IP I gave there, the remote AS, and all the networks that I want to advertise. And if I do Python 3 generate config hyphen config R3 core hyphen type core, if you see here, it has generated nothing because I haven't populated it. But if you see this part, which is the BGP configuration, it has neighbors statement, it has network statement, all the networks that we wanted to advertise, and this neighbor, the V6 neighbor that we added there. So yeah, that's how I am generating, that's how I'm using the front end to fill out the form, which creates a YAML file in the back end. And I'm using my Python code here to generate the configuration using this YAML, using the Ginger 2 template to give me this configuration. Talking about how I have code, configurations backed up, I have a systemd service called backupconfigs.service, and it's running. So I have this Python code, and what it does is it just logs into all these devices, all the devices that I have, all the management IP addresses, and takes up a backup config and stores it in this file, which is CFG's file. So if you see here, we have CFGs, and for now, I don't have multiple configuration files for each of these routers at different timestamps because of the space this VM currently has, and I've almost exhausted 98% of it. Uh, but for now, I'm just if there is a change detected in the running config of any of the devices, it backs up here in r1.cfg, and as you can see here, it's the entire running configuration. And this entire repository is then stored in GitHub. Like as you can see here, I have all the configurations mastered in GitHub. So yeah, that's about it for this assignment. Thank you.